All right. Good morning, ladies and gentlemen. Good evening, rather. Welcome to today's segment. All of you who are logged in from Facebook, YouTube, and LinkedIn want to warmly welcome you as you join us today. I think we live in some of the most challenging times we have faced, not just as a nation, but globally. We live in some very challenging times. And I think that in the midst of these challenges, in the midst of some of these difficulties, I think there is no greater moment to look into the future with optimism than right now. And that's exactly what we're going to do today. And we focus on the topic of data science beyond 2022, with a special focus on data visualization and explainable artificial intelligence. Ladies and gentlemen, on my left-hand side, we have with us two distinguished guests who will speak to us on some very exciting topics. So we are going to have a lot of fun today, a lot of focus on some futuristic, exciting areas that all of us are going to just dive in and enjoy today. So before I introduce both Dr. John and Professor Nirmali in detail, I'd like to welcome to the podium the Dean of IIT, Ms. Naomi Krishnaraja.
Good evening, everyone. A warm welcome to all of you who are joining in this webinar on data science beyond 2022. Ladies and gentlemen, my task today is to introduce the two speakers for the evening. The first speaker would be John Isaac, the head of School of Computing at RGU. As such, is responsible for strategic planning and future directions of the school, teaching, and research. Dr. Isaac research interests lies in the use of visualization, modeling, real-time simulation in aiding comprehension of complex information. We also have our second speaker, Professor Nirmali Veerathunga, who is a professor in intelligent systems at the Robert Gordon School of Computing, with over 20 years of experience in computer science and artificial intelligence, research and education. She's also a professor at the Norwegian University of Science and Technology, and best known for her work on case-based reasoning and personalized decision support systems. She serves on numerous program committees, including premier international joint conferences on AI, AAAI, and ICCRB. She leads the Artificial Intelligence Research Group at RGU. And so these distinguished personalities are going to speak to you, and I'm sure you're going to be excited about what is beyond 2020. Thank you.
Thank you, Ms. Naomi. Ladies and gentlemen, that was the Dean of IIT. I will not take any further time and just invite to the podium Dr. John, who will talk to us. You've heard the introduction, and Dr. John, it's over to you.
Thank you. Just make sure I can share content here. Yeah, that's right. Thank you. There we go. So thank you for that wonderful introduction. What I'm going to tell you about today is an aspect of interactive data visualization. The kind of research that I'm going to talk about, I'm going to do this using a number of case studies of previous examples of where this has worked. But the kind of work I'm interested in is about explaining complex information to people. A lot of the data that exists in the world at the minute, and the data that we create, and the complex algorithms that we are all involved in using, often produce data that can't be understood by the people making the decisions. So what I'm going to talk to you about today is a couple of case studies that try and create a common language using visualization to explain some of these complex data sets. So important decisions are often made based on complex information, complex data sets, complex packages of data that we as computer scientists understand, but often the people who are making the decisions don't. The decision support tools that do exist are often created to help this process. Decision support tools created to help people understand the information and to help people create decisions based on that information. The idea behind this research is we try and create a common language for those decision makers. Often, though, the way the data is presented is it's presented for experts. The data can become quite impenetrable to non-experts, people that don't understand how that data is presented, don't understand where the data comes from, and therefore feel unable to make a decision based on that data. The problem is when we make decisions based on this type of data, those people can feel then left out. This is particularly important if you're trying to involve the general public in a decision. If you're trying to involve people who are from a wide range of backgrounds, a wide range of experience, you can't expect them to all understand data in the same way. More importantly, it may be a non-expert making the final decision. So I'm not going to say anything about politicians, but a lot of them will not be experts in the data that we present to them. But ultimately, it's them that maybe then have to make a decision. So similarly with CEOs of big companies, they may not understand the data that's being presented to them unless we can create some kind of common language that helps them to do that. So the core idea of interactive visualization is to use visualization to create new ways for anyone to interact with data, ways that don't rely on the background or previous experience, ways that are tailored to the type of data being shown, and ultimately creating a common language, allowing anyone to understand the data that we're trying to present. So as I said, I'm going to demonstrate this with 4 or 5 case studies of where research in this area has happened before, and show you some of the outcomes of those projects. The first one I'm going to talk about is a tool called the Sustainable City Visualization Tool. Now this it's a wee bit old, it's probably 6 or 7 years old now, but this was a tool that was created to demonstrate a sustainability data around a development that was happening in Scotland. A development is actually still going on. It was a 20-year plan. This tool was developed to show the data behind. The tool itself is designed to help with sustainable city design. Sustainability inherently is a complex subject. It contains lots and lots of different facets of what we think about a city is. It may be environmental aspects, it may be human aspects, it may be things like water resources, economic, population, where people live. Lots and lots of different aspects feed into what we define as a sustainable city. Often the data behind sustainability is presented in quite impenetrable ways. Some of the images on the screen are different ways of showing things like temperature, things like heat loss. There's an economic graph in there, and there's also a topological layer graph that tries to show a map-based view of a particular area. This example here is a traffic model. This is a traffic model of a potential street layout for this city that was being redesigned. The traffic model itself there shows the amount of cars on a particular street and the direction of those cars. Now, unless you're an expert in traffic modeling, it's unlikely you're going to be able to gather that information from that 2D plan. And that's a good example of what I'm talking about. So plans like this are often presented to people making the decisions. And if they don't understand them, it becomes difficult for them to make a decision that is actually based on the data. So what this project did, the problem here, so to define the problem this project was aiming to address, it can be difficult for non-experts to understand 2D geographical information. So if you think about using Google Maps, using Apple Maps and looking at it, you get a 2D picture of the world. Now, if someone's trying to show you a development on that 2D map, it becomes quite difficult because you can't show the position or the context of the buildings. So this is the development plan with that traffic model presented on it. Potential solution is to start using interactive 3D visualization. 3D visualization taps into our inherent human ability to navigate in 3D. We do it every day. We walk around environments in real 3D. When you walk through a city, it's a 3D environment around you. So that means you don't have to concentrate on how to navigate the environment and can concentrate on the data that is being used to make that decision. So unlike a 2D traffic flow, you don't need to look at numbers and figures to understand how busy the traffic is. You can look at that in real time. So hopefully this little video will start. So as I said, this was a project created a number of years ago, and it turned this traffic model into a real 3D environment. The 3D environment is built on a custom games engine. So it was a games engine developed similar to games engines you might use to play games on PlayStation or Xbox or whatever. The city was developed within that. What it meant was that anybody could come and navigate the city in 3D, the development that was planned, but more than that, they could interact with it. You could change the locations of trees and see what impact that had on the noise of the traffic you received if you were standing in the area in the middle. You could play about with the levels of traffic and see what that actually looked like if you were standing at that point in the city. Unfortunately, the audio isn't playing here, but you could hear the actual noise from the traffic based off real traffic volumes, and lifting or moving the buildings then changed how you might hear that if you were working or walking to one of those buildings. What we also did was come up with ways of displaying information in that environment itself. A couple of different ways we did this. We created hopefully this video will start, both of them. We'll see if they pick up in a second. Yeah, they're going now. So we created a system where you could play about with what if scenarios. You could change the building material of a building, the look and feel of a building, and move the buildings about. By changing the material that a building used in its construction, that then impacted the sustainability of that building. If you didn't know about how maybe concrete affects a building's sustainability compared to glass, it showed you it in color. So you could see the building glowing red is less sustainable based on this model than the building glowing blue. What this meant was that anybody looking at this could see, actually, I can now see the impact of that. And then, of course, they could go and mine the data afterwards to see what it produced. But it gave a really nice overall impression to show anybody to kick off that discussion about the sustainability of this part of the city. The next case study I'm going to show you is to do with interactive culture. This is slightly different. This is the idea behind this project was to get people involved in the culture of an area where they had maybe forgotten because it had been redeveloped, or the stories had been lost in the last number of years since the area that I'm going to talk about had changed in use and changed in purpose. The project was based around a city, a very, very, very small city in Scotland. Scottish cities are tiny compared to cities in Sri Lanka, but very, very small city called Elgin in the north of Scotland. And it has a long history in cashmere. So the textile cashmere, and it produced lots of products over a large number of years, big mills to create cashmere products. What we wanted to do with this project was to create a collaborative approach to be able to document and enable interaction with some of the stories that happened within the city. So what you're seeing there the image on the screen is actually a 3D scan of the city. The 3D scan creates point clouds. I'll show you an example in a second. So here, the laser scanner in the bottom corner, the strange bulky object, that's a laser scanner, sends out laser beams, bounces off the buildings and creates a 3D picture of the environment. These are incredibly complex. They have well over 1 million data points in some places. Some of the bigger scans could be tens or hundreds of millions of data points. As you can imagine, again, a non-expert looking at that can find it quite difficult to cope with. The raw image that it puts out is that sort of red tinged one at the top. And the other image you can see with the little triangles on it is the positions where we took the 3D scans. The final image at the bottom is the recreated 3D environment of that city. What this enabled us to do was to create a platform where users, people who lived in the city, could come on and leave stories about the city. We could then collate those stories and people could interact with it and view the environment in a way that they hadn't done in a long time. They could share stories, remember stories, and see parts of the city that perhaps had been obscured by new buildings or new areas. Another example I'm going to show you is about political debates. This is I'll explain what political debates are in the Scottish term. So every time there's an election in Scotland, all the politicians get pulled into a room and they have to have a debate with each other. The leaders of all the parties are all there. But the thing about debates in Scotland is that all the politicians have a hashtag on Twitter. They have a Twitter account. The debate itself will have a particular hashtag. So if the debate's perhaps on the BBC, it will be hashtag BBC Scotland debates. So you're creating an environment where people can discuss the debate live while it happens on social media. What this project is designed to do is to be able to highlight the topics that actually cause discussion on social media. So there's a lot of things happen in these debates. Some of it causes a big uproar, some of it doesn't. Some of it is picked up by the press, some of it isn't. We wanted to identify what actually caused discussion in the public at the time when these were running. So during the debate, we collect tweets. We collect tweets live as they come in, all the tweets related to that hashtag of the debate. We then look at which hashtags are mentioning particular parties. So you can see the first graph there, that shows the volume of tweets mentioning the different parties. The different lines represent the different political parties. And we did that for the whole length of the debate. So it's about 90 minutes to our debate that we collect for. And you can see there are two parties clearly that have much more tweets. These were two parties who were having quite a fierce discussion during this debate. And you can see the peak in the middle, highlighting the amount of tweets that were happening as that, let's say, argument took place. The graph at the bottom then shows the sentiment of this and shows it along the same timeline. So you can see the peak, the very deep trough in that sentiment graph, slightly after the number of tweets being tweeted about the argument that took place. What this started to show was that actually there was a lot of negativity towards the argument happening during that debate. So it let political analysts look at this and actually get a better feeling for what was happening live during that debate. And all of this was recorded live. All of these graphs were running live. This wasn't the data collected after the fact and then the graphs created. These were being drawn live as the debate happened. So you could really see what was happening and what was important in that debate. We also built in some interactive data mining techniques into this as well. So the first graph there with the blotches on it has a number of topics that were raised during the debate on the left-hand side, and then how hot these are along the course of the debate. So you could tell minute by minute whether something that was mentioned caused a little bit of a blip or something actually caused an entire run across the whole debate. So that line across the top, that topic was actually mentioned every minute of that debate on Twitter, whereas some of the ones down at the bottom, they were mentioned once or twice and then never mentioned again. The thing about this was it highlighted which actual topics people were interested in, which topics were causing that discussion on social media. And then we also have a live tweet frequency. So we had second by second counts of who was, which political parties were being discussed more. All of these, as I say, ran live during the debate. So anybody could go onto the site, and this was all done on a public accessible website. So anybody could go onto the site and look at this stuff happening live and follow along the political debate as it happened. And then the last case study I'm going to show you is historic building modeling. This is a bit of a catch-all case study that includes a number of different aspects of both data and 3D modeling. The purpose of this project is basically about evacuation of historic buildings. In Scotland, we have lots and lots of historic buildings, lots of castles, lots of Neolithic tombs, and these are all generally enclosed. It rains a lot in Scotland, so our historic buildings are generally enclosed buildings. The problem with these are that they get lots and lots of visitors, hundreds of thousands of visitors, but they don't follow modern evacuation procedures. So if you build a new building, you can model evacuation. If the evacuation is not right, if the evacuation process isn't right, you can put in new fire doors or exits or plans. With a historic building, you can't suddenly knock down a wall to put a fire exit in because the wall is extremely old and it wouldn't be a good thing to do. So what we wanted to do was to create a decision support tool to help the owners or the managers of these historic buildings understand what would happen in an emergency scenario. So the first one I'm going to show you how all this came about is a chambered tomb, and you'll see what a chambered tomb is in a second. I've got a wee video in a little island, a tiny little island off the north coast of Scotland called Orkney. So I'll let this video play and you'll see, I'll talk a wee bit over it. But so Maze How is a chambered tomb. It is a mound in the landscape, and inside that landscape there's a chambered tomb. Now, this is where Neolithic people used to bury ashes, really. We don't know exactly what it was used for. This one is particularly important because Vikings broke into it and left some lovely graffiti on the walls. So we have an ancient Neolithic tomb with Viking graffiti. To enter the tomb as a visitor, you have to crawl down this tunnel. I'm not very tall, but I had to crouch significantly to get down here. Typically, it takes a normal person about 17 to 23 seconds to enter and exit this tunnel. There's around 20 people allowed in the tomb at once on a tour. And as you can see, you walk up and down this tunnel to get in and out. The chamber is quite small in the middle. You'll see the chamber in a second. What we wanted to do was recreate this environment. So again, we built a games engine that ran as a egress model. We were able to fill this with people and then define how fast those people moved, how those people moved, and what sort of body sizes they had. And then we created the evacuation. We told the models to leave, and they crouched down and they walked down the tunnel. Oops. The problem about this scenario is something called the slow walker. So if everybody walks at the same speed, everybody gets out of the environment, gets out of that tunnel in about 150 seconds, which isn't that long. If there's an emergency and it takes 150 seconds to get 20 people out, it's quite reasonable. If you swap the order around and have some people that are moving slightly faster or slightly slower, that's the graph at the top to the right-hand side. Again, everybody gets out in a kind of reasonable time. What happens though if you suddenly have someone who can't walk as fast? This could be someone who has fallen over and injured themselves in the historic building, or it could be someone who has already arrived with some kind of mobility problem. That's where you start to get an issue. If someone in front of you is moving slower than you want to move, that causes anxiety. It also means that it could be a risk. It could take a lot longer to exit that environment. If you have someone who walks very slowly, this becomes even more of a problem. And in an emergency situation, people panic. The tunnel I showed you does not allow two people to pass. If there's someone in front of you moving slower, your only option is to wait. And that causes an issue in an emergency evacuation. When we visited the tomb to do some of this analysis, we did see someone who took an incredibly long time to exit the tunnel. They took roughly 4 or 5 times longer than the average person took to leave the tunnel. We were surprised at how long that was. We hadn't calculated that. We'd looked at much slower, much faster evacuation times, but this caused a massive impact on how long it took people to get out of that environment. So we created a model. We used the same 3D technique that I showed you for the Elgin project that scanned the environment. So the scans were done by Historic Scotland, Historic Environment Scotland. And from that, we were able to create a model of the building, of the chamber itself. We then looked at how people moved within the tunnel, and we created and rigged real body types to move like those people who were visiting the environment. So the crouch, the stoop you have to do to get out of the tunnel. And then we created people who were of a whole range of different body sizes. So right from very slim people to people who had eaten far too much. And that then impacts on their mobility and the amount that they can actually crouch to move out of the tunnel. So what we were trying to do was recreate this real situation. And eventually we built a full scenario. So the one at the top is everybody moves at a random speed, but that random speed is in normal parameters. You can see how long it takes them to exit the tunnel. At the bottom, we have one very slow visitor. What we wanted to demonstrate to the managers of these types of buildings is you might need a better way of managing who is going into these tombs in case there is an emergency. And you can see at the video at the top, everybody has already exited. The video at the bottom, we're still going. And we're still going. You can see how long this now is, and you don't get that impression from a graph. A graph is figures, you don't see that. As soon as you see this in a video, you start to get the impression of how anxious that must be to be stuck in that kind of situation. And you see it's still taking quite a long time. So the point of this project was to demonstrate to the decision makers around the management of these buildings that perhaps letting 20 people in might not be the right thing to do. Maybe if you have someone who is slower walking, only let 5 people in at that point, and then let more people in if they all have high mobility. So you can see how long that took for everybody to exit. It actually still hasn't exited from the bottom video. From this, we further developed the project through buildings both in Scotland and in Italy. And one of the things that became a big issue is spiral staircases. A lot of the historic buildings in Scotland have spiral staircases. These are essentially a vertical tunnel. You go in at the bottom, you come out at the top, and there's no way out halfway up. The walls are, meant to prevent cannonballs and things, so there's no way of exiting halfway up. So what we wanted to do here was to create a model that showed that aspect as well and showed the impact of different mobilities in exiting buildings with spiral staircases. So we created another custom model. Hopefully this video will play. Yeah, there we go. This a bit slower. So we created another custom model that let us basically create a virtual staircase. We could change the number of steps, the width, the depth, and the step depth of these steps. And we could see what impact that had on how people could move through these buildings. Obviously, it's not ethical to put a lot of people in a real staircase and then run them up and down it. So what this let us do is create an environment where we could simulate what it would look like with lots and lots of different people within a staircase. So the example here is just creating a couple of people and then creating a space, an initial space between them. And then in a second, you'll start to see how quickly that space closes when one person walks more slowly than another. So the slow walker starting on the staircase, and the faster walker is about to start walking, and you can see very quickly how that starts to cause a problem. If there are multiple people, this causes an even bigger problem because they are then all stuck trying to evacuate that system. It's all based on realistic movement. We captured the movement of people on spiral staircases using motion caption systems. So we were able to capture real movement of the people and then remodel that and rig that in Maya and 3ds Max to create the real people. And again, we did this with different body sizes and mobilities. And we ended up with an evacuation system that I'll show you this just now. It takes a wee minute to set this up, but we created an entire customizable environment where you could set the number of staircases, the number of rooms, and the number of people, and you could place however many people of however many body sizes and mobility aspects you wanted, and you could see how quickly they could then evacuate from a building with this type of staircase. And you can see that's exactly what it does. It creates the staircase and then shows how people would move throughout that. When we put it all together, this is what we created. We created this fully customizable environment that let you essentially rebuild a historic building or rebuild your ancient castle, customizable to any kind of castle or environment, and you could fill it with people and see how they worked. Some of the work we're looking at with this type of simulation now are also including things like social distancing in this. So how do we model for when people also need to keep a certain distance apart, and what impact will that have as well? So creating this custom environment that could then explain to people what the impact of these types of building management decisions could have. So just in conclusion, visualization provides a really powerful way of ensuring the data we collect, generate, and analyze can be understood by the target audience. Decisions that come out of data analysis are not only as good as the data we put in. There's always a saying, rubbish in, rubbish out, or good data in, good data out. It isn't only about that. The data is only as good, the decision that's made off data is only as good as our understanding of that data. If we have amazing data, but it isn't understood by the people making the decisions, then that data won't be used properly in that decision. So it is vital that we do ensure that the data that we're using is understood by the people who are eventually going to use that and make decisions from it. So thank you very much. Yep.
Thank you so much, Dr. John. That was very exciting, particularly interactive behaviors that come into the whole concept. What really, sounded a note with me, and I'm sure there are going to be quite a few questions coming in your direction. So ladies and gentlemen, I want to encourage you to send in your questions as well. You're logged in from Facebook, YouTube, or LinkedIn. Please feel free to send in your questions. They will reach me, and we will present those questions to both Dr. John and Professor Nirmali as we go on. Okay, so let's move forward. And next we have Professor Nirmali Weeratunga. She is the Professor Intelligent Systems Research at the Robert Gordon University in the UK. And she's going to talk to us about artificial intelligence, particularly explainable AI, which is something, again, I'm sure that is going to grab your interest. So without any more time taken, Professor Nirmali, over to you.
John, you just said
all right.
Here. Thank you so much.
Okay.
Thank you to IIT for inviting me to share our latest research in explainable AI. I think everyone wouldn't argue if I were to say that AI is probably the hottest topic now in computer science, right? So and that can be seen because a lot of AI techniques and tools are being deployed. Many people are using, all the big tech companies are using it. It's every day in our life, everywhere, so you can't get away from it. But with that maturity of AI methods, we need to also consider some other aspects, such as this idea of responsible AI, because if we are going to allow machines to make decisions, we need to be careful. There's a lot of ethics involved. There's a need to be able to explain to people the decisions that are being made. So one of the important areas in responsible AI is to look at transparency with respect to explainability. So that's why this field of research is called Explainable AI, and by no means have we really solved it, but a lot of people are working. So at the end of the talk, my hope is that I would probably give you an overview of why we need to bother about explainable AI. I'll try and give an indication of the different types of explainable AI, or for short, we call it XAI or Psi, that people are using, and give you a very quick overview because it's quite broad. And then I want to focus on an area that we use, which is called case-based reasoning. I think Naomi, or you mentioned that area. This is an area that the School of Computing at RGU are quite well known for. In fact, next year we are I'll be co-chairing the International CCBR conference with another famous researcher from Dublin. So we have a good track record in this area. So what we do is we use some of our understanding of case-based reasoning and try to apply it to explainable AI. So I'll try and give you a flavor of what we are trying to do. And this year we were very lucky because we got quite a lot of funding from EU to try and create a framework for explainable AI. Because if we are going to talk about AI being deployed, we may want to talk about, how do you ensure compliance. And currently there are no frameworks in place. So lots of people are working towards achieving that. So let's begin. So if you look at explainable AI, I think one of the key concepts is this idea of transparency. And if you look at the common dictionary of what is transparency, as I've put there, it is the quality an object has when one can see clearly through it, or the quality of a situation or process that can be clearly justified and explained because it is open to inspection and free from secrets. So there's two things. There is the object as well as the process that went towards creating that object. And very often we talk about, understanding the black box or looking inside the black box, and that's exactly what we are trying to do with transparency. So some of you may know that AI became really popular with deep learning. And this is why we are also having quite a lot of validated degrees at IIT, the big data analytics, the AI and data science, and so on. And a lot of these methods involve what we call black box models. Essentially, we give it some data, that's a black box model, and then it throws some decision. The question is, what is actually happening inside that model, right? So it is not enough to tell, well, your loan is rejected, or you are likely to have some cancer. Often we want to know why was my loan rejected, so that is the need for transparency. But there are some other interesting aspects beyond trying to explain why something was rejected or not. It's the process of what data did you collect? Did you collect that data in an ethical manner? Does that data also contain human bias and unfairness? And has that unfairness and bias gone into the AI model? So there's a plethora of various issues that we need to address. And when we talk about transparency, it needs to cover both the object and the process. So here are some examples of, as I mentioned, suppose somebody applied to a bank to get a mortgage, and then it says, sorry, you don't have a mortgage, or yes, it's fine, you have a mortgage. The point is that different people may want different types of explanation. So if we have a data scientist who's building this AI model, a neural net to try and say, give a decision, the types of questions they might want to ask from a explainable AI system might be different from an end user. So a data scientist might want to know what are the attributes that are correlated with the decision of rejecting a mortgage or not, right? But if you think of perhaps a customer who goes there, they may just want to know, okay, my mortgage was rejected. Is that a fair decision? You know, why was it rejected? They are not terribly interested about the correlation and the accuracy of a model. They might really want to see things like, you know, people who had a income in this range who are similar to you also had mortgages rejected. So another interesting challenge we have with explainable AI is that we can't just think of it as a single solution. We need to personalize it to depending on your stakeholders that are involved. Another important thing about explainable AI is if we get it right, it might help us to create trust in the system, right? Because if we are using a system and that system is able to tell us why, perhaps we might have more interaction, as John suggested, even with visualization is a good way of creating that trust. It will allow people to understand to what extent they can expect accuracy. You know, you don't expect it to be accurate all the time. It only depends on the data that's given. So some level of expectation, the right level of expectation can be achieved if we get this explainable AI correct. And similarly, you might get different stakeholders. So one doctor might say, well, can you tell me which area, or this is, and then you could highlight that area. So for example, a lot of medical diagnosis involves what we call opaque AI models. So these are AI models that basically are very hard to explain because they are black boxes, right? So in that situation, as the image shows in a radiology or X-ray picture, you could identify a salience areas of importance. While another doctor might want to evidence base, you know, so when you say there's likely to be some malignancy here, another doctor might say, well, what do you have some evidence base? So then you may want to show alternative examples of other patients who are also in a similar situation. So I guess my point is that when we talk about explainable AI, there are lots of interesting angles and challenges and ideas that we need to bring into it. So if you look at the literature, when we read about explainable AI, fairness is a key concept that is often looked at. So what they're saying is, if we have explainable AI systems, it allows us to figure out if there is fairness in that model. So this is a very famous piece of work that is reported by this Dodge et al. In 2019. And what they did was they looked at a real AI system that was used for, correction, where judges are deciding whether a particular offender is likely to re-offend. And they were using this system to support their decisions. And what was really strange was that AI system already had a level of only 60% accuracy. And imagine a judge basing their judgments on that. And more importantly, the data was very biased, racially biased. So what these researchers did was they basically took this data set and they did a whole analysis of the data and looked at, what are the different types of explanations that we can provide that would have actually helped to understand that this data is unfair and we should not be actually using it to make judgments. And they found an interesting area called counterfactuals, which is an area which says, okay, if someone was identified to be reoffending, how can you change that judgment? What criteria would change that judgment? And what they found was, if you are a Black American, often it would say you are likely to reoffend. And if you were to change that attribute, you would get an alternative, better outcome, which is you are not likely to offend. So that kind of thinking is called counterfactual. So when you give a decision from an AI system, if you can give a counterfactual, that may actually help you to identify unfairness and so on. Another area that they found that was useful for explanations was to actually pinpoint what are the correlated attributes. So for example, I don't know if you can read it, but you see the feature relevance section. It shows that the person's age bracket is 4 times as more important as much as, another thing like where they come from, for example, or for the fact that they are American African. So the ethnicity, that also has a important aspect. So things like that helps people to understand if there is fairness in this AI system. And it turns out there wasn't, because the original data was already biased. Okay. Another reason why we need explainable AI is to do with GDPR, right? If you're using AI systems, people have the right to ask, why did I get this decision, right? So we need to be able to say something about it. So increasingly in European law and UK governments, they're all sort of pushing towards the need for explainable AI. And we have this thing called the right to an explanation, right? So what we're now probably looking for is things like, if right to an explanation is becoming an accepted, let's say, legal thing, it's not quite yet there, then we have to start thinking of compliance, right? So if we build an AI system, can we just deploy it, launch it? Probably not. We probably need to go through a compliance phase where we have some checklists, and then the AI system is probably now ready for deployment. But this is the exact area that we have been currently working with and trying to find new ways of standardizing and compliance. So if I have time, I will probably very quickly give you an idea about that. So if we are trying to solve this problem of explainable AI, it's always good to think, how do humans explain, right? So in literature, there's a lot of nice studies done about, what humans find important in explanations. And what they did was they looked at a Reddit. Reddit is a social media area where you can put questions and discussions. But they looked at this particular channel called Explain Like I Am 5. And essentially what they have are questions and people posting explanations. So that gave them a nice raw collection of data to analyze, right? So they took about a couple of questions in a particular domain, took examples of explanation, identified a whole sample of people to work in an experiment. And they told them, well, for these examples of explanations, can you rate what is a good explanation? And after that, they identify a whole bunch of criteria. And for these criteria, they said, can you say, does this explanation meet that criteria? And what they were trying to do was to see what were the criteria that humans find important when gauging that an explanation is good, right? So in that study, I mean, you can, if you're interested in the reference is there, but what they found out is that people like coherence. They like an explanation to be coherent, obviously. They don't like gaps. Everything needs to be explained and complete. And interestingly, what they found is they don't mind complex explanations as long as those explanations have some causal relationship. So if I'm saying that you would get that loan if your age is such and such in that bracket because of this reason, and then you say that reason is linked to another reason. So you can have to provide a causal link. If A, then B, then if it's B, then C. So humans like that kind of causal reasoning when we provide explanations. So a lot of research that we're currently doing is trying to understand what types of intentions do humans have when they go to an AI systems. And in that recent project, we are of course trying to create what we call taxonomies and identifying different intentions and so on. So I won't go to too much detail, but it is a really interesting area. Just to show you the amount of research that's going on in this area, there's a systematic review done by this Arietta et al. In 2019, and they have identified a whole bunch of explanations before the AI system is created, explanations while the AI system is working, explanations after the AI system is created. So if you're going to work in this area, it's good to try and focus which area is most relevant. So the area that we focus in the School of Computing is what we call counterfactual AI, but we also look at factual and semi-factual. So in this picture here, what we are trying to do, it's a very famous, what we call hello world application for deep learning, right? People who are doing C will have this hello world programs, but this is the hello world for deep learning. And what we do here is we have images of characters that are written by humans, and the AI system needs to recognize them. And it may recognize them correctly, or sometimes they might do it incorrectly. So here the test image is 9, and we want the AI system to recognize it. It may recognize it as 9, but if you want an explanation, for a factual explanation, it can show another alternative 9 and say, well, I think yours is a 9 because this is very similar to what you have written. So that is called factual explanations. Then the opposite of that is counterfactual, where you would say, okay, this is you have given me a 9. If it looked like that other picture, then we would have said it's a 4. So that's a counterfactual. Then there's an in-between one, which is called semi-factual, which is, okay, you showed me a 9, I recognized it as a 9, and I think even if it looked like that, I would still call it a 9. So the idea is that if an AI system can provide these factual, counterfactual, semi-factual, we begin to understand and see inside the black box. It's really quite an interesting area, this counterfactual research. So what I want to do is I'll probably skip some of these areas and go to what we do is with the case-based reasoning. So as I mentioned, this case-based reasoning has a very long history in artificial intelligence, and this idea of explanations were actually discussed as far back as 1988, and it also comes with this area of psychology as well as an analogical thinking and reasoning. And why it is so good is that case-based reasoning always looks at analogy, things that were similar in the past, and uses similarity to try and explain things. So if you think of the legal domain, precedence is often used, isn't it? If we see a case of this nature in the past, we use that case to try and explain the current situation. So it naturally lends itself to explainable AI. But then the question is, CBR itself is an AI reasoning methodology, which may not have the levels of accuracy that a deep learning neural net might have. So what a lot of researchers are trying to do then is, can we couple them together? Because CBR has the explainability advantage, while deep learning has the advantage of accuracy. So there's a lot of research now trying to combine them, or what we call twinning systems, where, for example, we might get a neural net here, which is like a black box, gives you a response or an answer. What they do is they have the same training data that was used for the deep learner as the cases from the CBR system. But instead of using the raw data representation, what it does is, if you're familiar with neural nets, you will know that we have hidden layers. And what each layer does is create a very compressed and better representation. So instead of using the raw representations, what the CBR would do is take these compressed representations from the neural net and use analogy. Say, okay, here's a good compressed representation. I'm going to find another similar one, and I will show it to the end user using the raw data. And so what we are then trying to do is to ensure that the CBR is functioning almost like the deep learner, and we can put them together and give explanations. So there's then a lot of research going on, well, what happens if the CBR doesn't exist? And then the next type of research is looking at, okay, if it doesn't exist, can we simulate and create some perturbations of data and then somehow create what we call a surrogate database? So again, I've put some links there. If people are interested, they can go and look at this type of research. So the counterfactual explanations are the ones which are most interesting. So for example, here we have loan application query, and the loan applicant has got an outcome which is rejected, right? So when we talk about counterfactual explanations, the explanation will look something like that, which would say, if you had applied for a loan of, let's say, £10,000 less, or if you increased your monthly payment by £100, your loan would have been approved. So counterfactuals are a kind of explanation which tries to take a current decision and explain to the user how they can turn it around to make it a better outcome. And that can be useful for a lot of different applications. And so case-based reasoning naturally fits with this area of counterfactual explanations, because we're working with cases. We can show a given situation and show a case for a better situation, right? So it turns out that this area of counterfactual thinking is natural also to humans. Often we think that way, but importantly, it also accrues benefits from previous research in machine learning, where a lot of work was done to see what are the features that are important in order to come up with a decision. So we can make use of all that research that went back then, but also benefit from the research that from a different discipline, which is psychological research, where they say that humans often want to create a situation that is beneficial. So we think of situations like, if I had done that, if I took that route, I might not have got caught to traffic on that particular road, so that is called counterfactual thinking. So what explainable AI is trying to do is, if we come up with an outcome from an AI system, can we generate a counterfactual and present it to the end user, so that the end user can at least see, okay, I got a rejection, but if I do these changes, I might end up with a better outcome, right? So that is the idea of counterfactual AI. So in order to generate this beneficial scenarios, if you like, we want to create these counterfactual cases that have particular requirements, particular specific requirements that make them good. So we want to make sure a counterfactual is as close to the current situation of the stakeholder as possible, because if you give someone a counterfactual scenario which is way different from their current situation, there's no way they can achieve it, right? So for example, if you're trying to apply for a loan and your monthly income is, I don't know, £30,000 or something, and the counterfactual is saying, oh, if you got £60,000, you would get a loan. That is not very helpful. That's not helpful to the end user. So when we create counterfactuals, we need to find counterfactuals that are close as possible to you, so that you can evolve into a more positive outcome. The other one is sparsity. We don't want to ask the person to change a lot of things about them, change their job, change their location, change their marital status, whatever. We want to find counterfactuals that will find minimum changes to achieve a better scenario. So like this, there are quite a lot of interesting requirements that are identified as useful in order to create these artificial scenarios for explanations. So if you look at research, people who are working on this are using optimization techniques to generate alternative counterfactuals. And with most of them, what they do is they are trying to create a scenario which has a different, better outcome, and as close as possible by sort of generating perturbations and so on. But the downside of that is that when they create these artificial scenarios, you can have these out of distribution things, like, for example, I don't know, asking someone to do something that makes no sense, or creating an alternative situation where the data is out of range. So optimization techniques can lead to counterfactuals that are not sensible. So this is why we have discovered that case-based reasoning is actually a superb mechanism for generating counterfactuals. Why? Because it has this precedence of evidence or case-based. So when we find an end user with a particular situation, we can dive into the case-based or the precedence cases and find the most similar situation and that has a better outcome and present that case to the stakeholder or the end user. And so we've done some research, and recently we published this paper at one of the AI conferences. Again, there are some interesting points about how to decide which paths to change in order to achieve a good counterfactual. So that's those are the research questions. So if you're interested, I'm not going into detail, but I have put the reference there. Now, once we generate these counterfactuals, how do we actually present it to the end user? Actually, what we do is we present it as a natural language piece of text. So, for example, that first example here, can you see the, yeah, it says Moodle Data Set. Basically, what we did was in one of our AI modules in one semester, we collected the Moodle footprint of all our students and looked at, what did they access, and was it the tutorials, was it the videos, and then got a full footprint for every student. And we also got their grade. So supposing somebody ended up having a bad grade, we could use our technique and say, here's a counterfactual. People who are very similar to you, who did this bit slightly differently, actually managed a better grade. So that's how you would use a counterfactual. Then we also looked at another public data set about asking for loans. And again, you can do similar things. If someone's loan was rejected, you could come up with a natural language generated piece of text, which would say, something like the loan applicant would be successful if the loan amount is reduced by $1,000 with no recoveries and managing an increase in both the last payment by so much and so forth. So it gives you a easily understandable piece of text explaining to them how they can change their situation to a better situation. These are also some examples. So I will finally finish off with this very exciting recent project that we got funded in the School of Computing, and we call it the IC project, and it's about intelligent sharing of explanation experience by users for users. And it's an EU project with a couple of institutes, so Complutense Madrid in Spain, University College Cork, BT France, and we have a whole bunch of other companies as well. And I think what was novel, why we won this award was, or this fund was because we acknowledge the fact that there are many types of explanations out there, as I showed in literature, and different people need different, benefit from different angles of explanations. If we can create a case base of, for example, this type of user with this type of AI system benefited from this form of explanation, that is a piece of evidence or experience that we can store, so that if in the future another end user with a similar application, whether that is in loans or finance or banking or with a particular neural net comes to us, we can say, we recommend you use this type of explanation for this stakeholder. So collecting that evidence base of experiences was thought to be very novel, and I believe that's why they sort of decided to fund our project. It just started and we have another 3 years or so to go. So that's why the last point there is, it is a platform to try and gather explainable AI best practices, which eventually can then lead to standardization. Yeah, because for different types of applications of different people, stakeholders, if we know what are the best practices, that allows us to create the checklist that is needed for compliance. So that's sort of the direction that we are heading in. It is, of course, there's a lot of challenge there, because you can't just build something and expect everyone to adopt it. So we will only win with this if we are able to attract universities, research people, and as well as companies to share their practices. By share, I mean they need to provide us with some of the AI models that they are using. They need to provide us with some ideas of the stakeholders that are using. And we also need to find a way to get feedback from them as to whether or not the explainable technique they are using was useful or not. So it really involves a lot of interaction with a lot of people. Another interesting concept that we have recognized through this project is that, as I said, not only does different stakeholders require different types of explanations, it is actually a dialogue. So for example, they might ask the AI system, why did I not get this rejected? The AI system might say, because these features are such and such. Then they might say, okay, can you show me other people with those features who also got rejected? So it is a dialogue. And at each dialogue point, they may require different explanation strategies. So that throws in another level of complexity. So what we are planning to do is to start with basic explanation strategies and then see if some of them can be combined to create hybrid explanation strategies and so on. So an important part of this project is to have a lot of interactive, what we call an evaluation cockpit, because suppose somebody creates an explanation strategy and they want to test in the company, is this strategy useful for my end users? They need to have a way of interacting with some system and getting feedback from them. So again, we need to find out, in order to get feedback, what are the right questions to ask? And that's why I said in the literature, it's good to try and find out how do humans actually do explanations, because if we can understand that, then we can develop some criteria to evaluate the goodness of the explanations. So as I said, we are trying to work with the companies. So these are some of the companies who are currently on our project. So Bosch and BT and GY is a SME actually at in UK, but also Canon Medical are working with us. So if you know any companies that are using AI systems, has data, are interested in explainable AI, then we would like to speak to them. Right, so conclusions. We think case-based reasoning has an important role to play. I hope I gave you a flavor of the importance of explainable AI. And whilst there are many techniques, we think this counterfactual AI has a particularly nice place in a lot of different applications. It's still not solved, lots to do. I just want to say thank you to our XAI team at RGU. So thank you for your attention.
Thank you so much. Thank you so much, Professor Nirmali. And I think I think both of you, Dr. John and Professor Nirmali, touched on some very exciting topics, and quite a few questions are coming in. So I'm going to take it as we go. Ladies and gentlemen, this is the panel discussion time, and you are free to send in your questions. They will reach us if you send them on whichever platform you are logged in. Okay, so let's start things off. And Dr. John, I'm going to focus on you for a moment. Okay. And you mentioned interactive culture, and that obviously would require quite a few people in the public domain to actually participate in sending data in. Right now, how, Dr. John, would you validate the data that's coming in? I mean, there could be a lot of data that is false, that is inaccurate, that is even purposely fake. How would you determine what data is good, what data needs to be dropped, and so on?
For that particular project, it was hosted on the environment that we let people navigate and add data and stories to was hosted on a public website. So you're quite right, there could have been content put on there that wasn't appropriate. For that particular project, there was it was all moderated. It was moderated by someone who looked at the data that was coming in. As I say, it was quite a small city. It was quite a small area of a city, so there wasn't, millions of bits of data coming in. It was quite a small number, so it was able to be moderated by a human looking at it and checking that the data was appropriate before it was published. But there are a number of techniques you can do, and some of the ones that Nermali was talking about in her talk, that you could do to automatically do that and run through and try and remove data that looked anomalous or inappropriate in that type of public environment.
Right, right. Okay. So in the example you just quoted, you had to have a human intervention where everything was monitored case by case or data by data.
Yeah.
Right.
That's right, because it was based on a historical, cultural project. It was someone who knew what looked appropriate for that project. So it was a historian that looked at that data.
Okay. Another one. Dr. John, you mentioned the historic building modeling project, right? And you did talk about quite a few tools that you use.
Yeah.
Now, in reality, in a broader sense, how costly would it be to have, the equipment in place to actually be able to do something in a mass scale?
Yep.
Is it something that's costly? Is it something that's practically deployable into society? How does it?
If you wanted to do a full 3D scan of a building, you need the 3D scanner to do that. However, if you wanted to do a low resolution scan, you can do a technique called photogrammetry, which you can do with a pretty standard camera. You take millions of photographs, you merge them together with some software and create a 3D model. What we've done in the final stages of the historic building project is to create this system using a freely available games engine platform that then we've built the code into to be able to allow you to create this virtual representation of any sort of castle or any historic building. So that can be done quite cheaply. It's time rather than time cost rather than software cost or hardware cost. The real 3D scanning is expensive, but actually once you know the system and can create a system of abstract, looks nearly like what you're trying to get to, you can do that in the games engine, and it is just time now that we've built that tool to be able to do that.
Okay, I love the example you showed us of the staircase and the people moving across. I watched something similar just recently in the latest Bond movie. 3D scanning of the building.
Yeah,
very interesting. Professor Nirmal, if I can jump to some of the interesting things you mentioned and a few questions to run your way. One is this whole dependency we have on AI systems, right? I think we were having this conversation just before we started with the Tesla vehicles, right? The cars that are out there running purely on artificial intelligence when it comes to this auto driving capabilities they show. And just recently, I think it was this morning that I read of another accident, right? Where the car decided it needed to stop when there was nothing in front of it, and it pulled on the brakes on a highway, and your car started bashing behind it. Now, how do we determine? Well, where basically people are putting their lives in the hands of an artificial intelligence system. Now, how are we going to determine what mistake the machine made and why it made that mistake in order to make things safer in the future?
So I think that's exactly the place where explainable AI can help. Unfortunately, in this situation, it's after the event occurs, but let's suppose you create simulations like what John has created. You could run them and see, at which situations does it create a crash. And then even if you use techniques like counterfactuals, what we can do is, what is the scenario that would have avoided that crash? So that could be actually one way in which you could apply explainable AI to further understand what's going on. But it also opens up this whole other area of ethics. I think we discussed that as well, isn't it? And about liability. I mean, who's liable to such accidents? Is it the model, the AI, or is it the person who collected the data? Is it the person who trained the algorithm or designed the architecture? I mean, I think those are all gray areas that possibly needs to be solved. But I suppose if we have this notion of compliance, as I said, it would at least slow down the need to rush and deploy AI systems without, properly being tested or something like that.
Right. Interesting, because you mentioned the bias factor, the creator of the AI engine being possibly biased, that possibility is there. So a body like the one you were mentioning would have to be able to be neutral and actually validate the fact whether there are biases involved, etc. Right?
Yeah. So I mean, a good AI framework would XAI framework would be something that can actually help to tease out if there is bias in the data. It needs to be able to tease that out and put it out there, so that they can understand why that decision was there. I think there was a news article where they had used, is it Babylon, a medical AI system, and it was found to be quite biased towards females in terms of, was it heart attacks or something like that. So basically, if you put the same symptoms into the system and you had a different gender, the outcome is going to be different.
Yeah. Oh, I see.
Yeah. So if you put the gender male, it recognized that it was an emergency, while if you put the gender female, it recognized it was not an emergency, given the same symptoms. So that's another example of where the data is biased, similar to the one I was showing from those researchers who have done with the Compass system, where they got a collection of data about reoffending. So the chances are that if you put the same criteria and one was American African and the other one wasn't, you might get two different judgments. So that's another example of unfairness, which can be identified through explanation methods.
Right. So Nirmal, what you're saying is that right now we don't have an independent body of that nature in existence.
Not at the moment, but lots of people are working on it. So for example, in America, there's the DARPA who's working very hard on explainable AI. In Europe, there's lots and lots of research teams on XAI. Every year, there's XAI workshop twinned with a big AI conference. So I think they are at it, and so hopefully we'll get.
Okay. I want to raise a question that has come in from Facebook, and I'm going to read this word to word. It's from Kripa Prasanna. So Prasanna, thank you for sending this in. The question is, does counterfactual work on computer vision-based scenarios? Example, if the model classified as animal is a dog, can a counterfactual be generated to say why it was not classified as a cat?
Yeah, yes, you can. Yes. So there's another interesting area where they call generative models, where they are trying to generate images which are very like real images using deep learning techniques. So if you could combine a generative AI model algorithm, for example, with a counterfactual XAI, you could probably do that very well. I'm sure there are people who have already done that.
Okay.
Yeah.
Okay. Interesting. Just want to raise another one because, like we said, we're putting so much trust on artificial intelligence systems, right? But I mean, even between human beings, it takes time and experience to build trust. Now, how are we going to build trust on systems that are on machines that basically we can't interact with like human beings? We don't know how they think. How do we build trust?
So, I mean, it's a good question. If we think, how do humans build trust? It's about meeting expectations, isn't it? It's about, I have an expectation from you and you meet that expectation, then I tend to build my trust, right? So if I have a very high expectation and you are unable to meet that, it's hard. I mean, at least from my personal view, my trust is lost. So I think there is a strong link between expectation and trust. So if there's a way we can very accurately indicate to what can we expect from this AI system, then we are not setting the bar too high or too low. And you see what I'm getting at?
I totally get that. Okay, so it's about setting a standard of expectation.
To be able to accurately measure and indicate expectation. So given this AI model, we can expect this level of accuracy, or it is likely to make errors in this type of problem.
Right.
And those expectations are laid out.
Right. And I suppose repetitive, getting it right repeatedly again and again over a period of time also helps build trust again.
Yeah, absolutely. With also that explanation, because if, for example, we take the medical domain, they are very reticent to accepting decisions from machines, right? So if you are saying this is the decision, it is much easier if you can explain the reason, whether by showing similar patients or showing some saliency visualizations. They are more likely to understand the decision, and then they can decide, do I want to trust it or not. Actually, there was a nice piece of work done by some researchers in a very well-known XAI algorithm called Line. I didn't have a chance to talk about it. What they did was they took a whole collection of images of I think it was wolves and something else. And they found that the AI system was very good at recognizing the wolves and the dogs of something, two types of animals which are hard to differentiate.
Okay.
And when they used explanations to figure out how did it get it so right, it found out that it was a snow background, a lot of the images of the wolves or whatever that allowed it to get it right. Yeah, but that is a wrong wrong AI model, because
the focus was not on the animal, it was on the background.
Yeah, and if the background's changed, it would get it completely wrong.
All right. Okay. All right. Interesting. So data science and artificial intelligence. Can we talk about the marriage of these two subjects? How do they work together?
So you want to?
You go ahead first.
Right. So I think this data science, as it says, is how do we work with data? Yeah, the different methods of cleaning, pre-processing, analyzing, and using that data to create models and so on. AI is a little bit, I think, more on the way in which we would think about reasoning and a little bit of cognitive analysis. Things like if we can, for example, if we can take text and put it into some representation that allows us the initial organization of data, but then what can we do with it, right? That is the AI part. We can create summaries, we can do classifications, we can understand dialogue, like you say something, the AI system will pick the important concepts in what you're saying and probably go and put it into some record. So that is the place where AI comes in. I think maybe John might have a different idea where the two come together.
Okay. Yeah, I think that's right. We create, billions and billions, if not quadrillions amounts of data, and often, as I said in the talk, often that data isn't always accessible to everybody who wants to use it. And a lot of the AI techniques that analyze that data and collect the important parts of that data are hugely important to kind of democratize the access to the information and the data that then people can start to make decisions on. And it is vital that the data and the models used to analyze the data are understood. And visualization and simulation often provides that method of understanding, particularly to non-experts, or particularly to experts in a different field than the data has been collected in or the data produced from. And there's the whole aspect of cognitive load as well. If you're presented with a decision that you don't understand based on data that's incredibly complex, that can cause an issue for if you're looking at lots and lots of different parts of data. If you imagine a doctor looking at multiple x-rays or multiple CT scans, you can see how that can start to become difficult. Or someone watching multiple CCTV screens looking for a particular event. When you start bringing in things like machine learning and augmented reality, displaying extra information on top of that and highlighting the important parts, then you're starting to link the human side with the data side that runs underneath.
John, obviously, data science is something that's really a hot topic today. And looking into the future, with changes in devices, changes in technology, changes in the way people interact with data and how data comes into organizations and cultures, etc. How do you think the work environment, the demand would be for a subject like data science?
I think it's huge. I think the world is facing lots of challenges. There are a whole number of global challenges. Now, these are environmental, economic, and societal, and data will underpin the decisions that are made in all of those areas. We have the evidence, and the evidence comes from that data, and that's where the decisions need to be made. So all aspects of a whole range of different employment opportunities, a whole range of different industries, right up government levels will need to understand and use the evidence that's contained in that data. And that's where data science comes in, the analysis and understanding of that information, of that data.
Excellent, excellent. Can I ask that same question from you, Prasanna? In terms of artificial intelligence, it's a subject that's been talked about from, I think, the days we watched Knight Rider in the 80s, right? And it's still a hot topic. What's the future like in terms of careers, in terms of job opportunities?
I think in terms of research, we are only at the stage of what we call narrow AI. By that, what I mean is like you have a particular application and you have data for that application, right? And then you build an AI model. And it is narrow because if you try to take that model and apply it to another domain, it just can't do it. But if you think of humans, like we take our intelligence and probably we are able to transfer it to other applications, so I don't know, some of the techniques that, the way, some of the things we might reason about a finance situation and how we manage to push our case to get what we want, we might be able to use that same strategy when we are going to get a job. So humans are very good at knowledge transfer, and they do it quite seamlessly. And that is a kind of what they call general, there's this notion of the need for general AI. So what we are currently at is basically narrow AI.
All right, okay. So do you see robots taking over the world at some point?
No.
All right.
Not anytime soon.
Not anytime soon. All right.
Not if you give explainable AI a chance, because that will ensure that humans have control all the time.
Okay.
Or responsible AI.
All right. Okay, excellent. All right. Thank you so much. I mean, I sincerely, all of us here at IIT, we sincerely appreciate your time and just being with us during this period. It's a challenging period, like we said before, and you're here with us. So thank you so much. We truly appreciate your time with us. So ladies and gentlemen, that brings us to the end of our segment with you today. Thank you for logging in. Have a wonderful evening.